Hi everyone, my name is Ki-Hong Chen, and this is the discussion section for CS161. And this is the week 3's discussion, so we will cover binary search. Before we start, let's talk about the prerequisites. Students should have some basic knowledge in algorithms, and they should be familiar with data structures such as Python list and array. Students should also know how to source the data structure, and they should be familiar with the Python syntax. So let's start. So we start with problem definition. So binary search is a algorithm for solving a problem that when given a sorted array A and a value Y, we try to find an index I such that A of I is equal to that value. Or if the number does not exist in the list, we will return -1. So here's the example. So here we have this list of 15 elements, and we want to find the index of 33 using binary search, and the algorithm should return index 4. Because in index 4, the number 33 is there. So let's continue. So the explanation. So given this sorted list and the number Y, we know the length of the list. That means we know the total number of indexes. So we want to pick the middle index of the list, which is the total number of indexes over 2. In the case of odd size list, we want to use the floor function to get the integer part for the middle index mid. And we want to fetch the number of the list as that index. And then we compare it with the given number Y. So if Y is bigger, that means that we want to continue our searching in the second part of the list, which is list of index mid plus 1 to the end. If Y is smaller, that means we want to continue our searching in the sublist of list from the first element to the index mid. And we want to continue this process of 3 to 7 until either we find the number Y or sublist is empty, and we'll return -1 in this case. The intuition of this algorithm is simple. So the comparison of list of mid index with Y will only yield 3 results. In the first result, they are the same number. That means we have found the index, and we will just return that index. And in the second case, where list of mid index is greater than Y, that means Y is at the left-hand side part of the original list, which is list of the first element to the mid index. In the third case, we will have the number is less than Y. That means Y is bigger, so it's in the second part of the original list, and that is list of mid index plus 1 to the end. Given these cases, we can minimize the searching time by skipping as many elements as possible after each comparison. Therefore, we should always pick the index of the middle index of the current list. So this is the exercise. We have already explained the intuition of these algorithms. And use this example, you can try to find the number 23 in this list and see how many rows do you need. You can pause the video and check back once you have finished. Okay, so I have assumed you have practiced by yourself. So in this example, let's go over this example. In this example, we have 10 elements, and so the mid index will be 5, and we will pick 5. In this case, when index 5 is picked, the list of index 5 is 23. So we have finished in 1 round. So let's continue. This is the pseudocode of binary search. In this pseudocode, they use the lower bound and upper bound to represent the sublist. So the lower bound is at the beginning of time. The lower bound is pointing at the first element in the list, where the upper bound is pointing at the last element in the list. So while we process this algorithm, the upper bound will move to the left and the lower bound will move to the right. So when the upper bound is less than the lower bound, that means in the index, that means that we have searched the whole list. So that means X does not exist in the list. We will return X does not exist. Otherwise, we will calculate the midpoint using the formula we discussed, and we will do the comparison as we have discussed before. And we will continue this until either we find it or we have processing the whole list, and we will end the procedure. So the running time complexity of the binary search, assuming that the list given is already sorted, the running time of the binary search is O of log n. Every time we cut the list to half, so the size of the list is half every time. This means that the running time complexity of the binary search is O of log n. So here's the recap. Binary search is an algorithm for finding the index of an element in a given sorted list. It is very efficient. And the main idea of the binary search is that we cut the list by half every time so that running time complexity of the algorithm can be minimized. Do you have any questions? Do you guys have any questions? If so, please email me. Thank you. Have a good day.